Yeah, hello everybody. Now we discuss the addressing modes of MSP430. I hope you know what do you mean by addressing mode. Addressing mode specifies the way in which the data will be accessed by the CPU is going to be the addressing modes. And here basically there are seven addressing modes are available for MSP430, and among them seven addressing modes are valid for source, and in seven only four are available for destination. What I mean to say is four addressing modes are valid for both source and destination operand, but only three more addressing modes are available for source but not for the destination. Okay, let me see the first addressing mode here, register mode. This is one of the fastest addressing mode and easiest addressing mode that is available in MSP430. It takes only one cycle to complete this. The mnemonic for this is move.w source register, comma, destination register. So by this, the content of R5 will move to the R6. The content of R5 will move to the content of R6. The left side will be the source and the right side will be the destination. And the R5 content will move in this R6. And these addressing mode is equally valid for all 16 registers that are available in MS430, with some exceptions here. Whenever PC is used, PC is going to be incremented by 2 before it is used as a source. And the constant generator CZ2, that is nothing but R3, reads 0 as a source. Whenever it is a source, it reads as a 0. And both PC and SP must be even. Hence, whenever they are used as the destination, the LSB may not be discarded. Means LSB should be 0 only to maintain it as the even. And SR can be used as both source and destination. And coming to the second addressing mode, calling it as indexed mode. And one more thing regarding register mode is that register mode is valid for both source operand as well as for the destination operand. And coming to the indexed mode. So indexed mode is just like an element in an array that is available in C. If you take an example here, move.b 3 within brackets R5 comma R6. The meaning of this instruction is the content of R5 is added with the 3, which becomes the address at which data is available that will be moved to the R6. So in this way, 3 becomes the index, which is going to be added with the base address R5, and that will be the effective address at which the data is available, and it will move to the R6. And this indexing mode is also applicable for both the source as well as for the destination. Means you can take like a move.b 3 within parenthesis R5 comma some 4 within parenthesis R6. That is also valid here. And this is about the index mode. Now coming to the symbolic mode, it is also calling it as the PC relative mode. PC relative mode. So why it is called as PC relative mode? For example, when you have an instruction move.w loop counter comma R6, and it internally assembler replaces this instruction with the move.w x within parenthesis PC comma R6, where x is going to be loop counter minus PC, where x is going to be the loop counter minus PC. So when x is loop counter minus PC, then it is added with the PC. Therefore, it becomes loop counter minus plus PC, nothing but the loop counter. So whatever the value that is available in the loop counter will be loaded into the R6. So why we are calling this as symbolic mode? Because here we are using a symbol like a loop counter. So this will be the symbol that can be used like an any user defined register, user defined value, or user defined variable, so that contains some value. So that value will be loaded into the destination register. So this we call it as symbolic mode, but internally it will convert in terms of PC, and this is also calling it as PC relative mode. And this PC relative or symbolic mode is also valid for both source and destination. Hence, the example we can give in this manner, like mode.w loop counter, comma some other some ABC. ABC is another loop variable. Then by the assembler, it converts like x brackets PC, comma y brackets some PC. In this way, it will be converted. Hence, this mode is valid for both the source as well as for the destination. Now coming to the absolute mode, name itself. Okay, so whatever the variable that we are going to use after the and symbol, ampersand symbol here, it will act like an absolute address. So that address is a complete address, so which holds the value, and which may be like a loop variable that we use in a program. It contains some data. That data will be stored or it will be loaded into the R6 register when we use in this format like move.b and appends and the P1 in comma R6. The meaning of this one is load the data from P1 in and move into the R6. But the assembler replaces this one as P1 in brackets SR comma R6. But SR is going to be taken as 0 because P1 in already contains the complete address. Therefore, it is to be added with 0. Therefore, the P1 in address contains the value that will move to the R6. And of course, the absolute mode is also valid for both source and destination. Hence, you can give like a mode at B ampersand P1 in, comma ampersand some P2 in. In this way, you can ampersand some P2 out like that. So this is the absolute mode. And coming to the fourth one, SP relative mode. Actually, it is one of the special case of indexer mode. But instead of taking a general purpose register, you are going to take a special purpose register, calling it as SP. Hence, it is calling it as SP relative mode. So, but the working is similar to that of the indexer mode, except that general register is replaced with a special register calling it as stack pointer. So these are useful in stack operations while pushing and popping this data. So when I say move.w to then brackets sp comma r6, the meaning of this one is the address that is available in sp is going to be added to 2, and the sp2 address contains some data that will move to the r6. And of course, this is also valid for both the source and destination. Hence, you can take for source as well as for the destination, the SP relative mode. Now coming to the fifth addressing mode, calling it as indirect register mode. Indirect register mode. So in indirect register mode, for example, if you see this instruction mode RW at R5 comma R6, now R6 doesn't contain the data. Now R5 contains the address of the data. R5 contains the address of the data that you can identify by using the at symbol here. Therefore, from R5, you are going to get the address, go to that address and get the data and move to the R6 and move to the R6. So in this way, you can you can have this indirect register mode. Of course, this is not valid for the destination. So like move at R5, comma move at R6, you can't do this. That is not accepted by the CPU. But to have an equivalent reverse indirect register mode for making valid of destination. You can do in this manner like mode w r6 comma 0 within parenthesis r5 means so whatever the data that is available in the r6 that will move to the address which is uh, which is available in the r5, which is available in the r5. So in this way you can do the reverse indirect register mode for making valid for destination, but it is not actually valid for the destination. Now coming to the one more indirect auto increment register mode. This is a special case of the indirect addressing mode. It works just like the indirect addressing mode, except that after the uh, execution of it, after the loading of the data, so the address is going to be incremented. If it is byte, that address will be incremented by 1. If it is word, it is going to be incremented by 2. For example, mode W at R5 plus R6. So what happens? R5 contains the address. Go to that address, get the data, and move to the R6. Then after, R5 will be incremented by 1 or 2 based on byte data and word data. And just like indirect addressing mode, this indirect auto increment mode is also not valid for destination, but you can construct by using the instruction as follow here mode w r6 comma 0 r5. The meaning of that is the data in r6 is moved to the address which is given by the r5, but after that the R5 value is going to be incremented double, as this is the word. Hence we need to we need to increment the R5 value, that is the address, by 2. In this way you can construct equivalent addressing mode for indirect auto increment mode to make valid for destination. And coming to the last addressing mode that is available in MSP430 is immediate mode. In immediate mode, instead of at PC place here, we'll be having some hash, some data. That is the immediate data that can move on to the register calling here R6. That is calling as R6. So in this way, in the immediate mode, so the source itself is going to be the data. The data will move to the R6. And just like the earlier addressing modes, this immediate mode is also not valid for destination. Means from R6, the data cannot move to the immediate data. Therefore, immediate for immediate mode also, that this mode is not valid for destination. So in this way, so the first four addressing modes are valid for both source and destination, and all seven addressing modes are valid for both, are valid for only source. So this is all about addressing mode. Yeah. Thank